Welcome. So we're going to finish up quotient rule. Below are the graphs of two functions, f of x and g of x. Let p of x equal f of x divided by g of x, and let r of x equal sine x divided by f of x. You use the graphs to answer the questions that follow. Right? So we want to find p prime of 5. All right? So we're going to use our graphs here. That's all we know about f of x and g of x. All right, so f of x, we're looking for 5. All right, let's look at 5. All right, so remember let's first of all, let's write out the derivative. All right, that will make less errors. All right, so always write the formula on these ones. All right, let's write that here. Write the formula first, because you are apt to make an error and do something silly like make the derivative be the quotient of the derivatives, and it is not that, right? We've seen that. No way that. All right, so p prime of x is going to be equal to, all right, so our denominator is g of x is going to be g of x times the derivative of f of x, so f prime of x, minus f of x times the derivative of g of x. All divided by g of x, g of x squared. I had to look for a minute to see who was in the denominator again. G of x squared. All right, so now let's find everything. All right, so f of x, that's just going to be the value you see in the graph. All right, so and specifically we're looking for f of 5. So let's since we're looking for p prime of 5, let's write underneath this p prime of 5 is going to be g of 5 f prime of 5 minus f of 5 times g, oops, that's not in parentheses, times g prime of 5. And I would write both parts here. All right, you won't make as many errors because it's easy once you have it written out correctly. Oops, excuse me, g 5 squared, g of 5 squared. Okay, all right, and let's find everybody. All right, so since I switched colors, I'll switch colors. All right, so f of 5 is, couldn't make it an integer. All right, 1, 2, 3, 4, 5. I'm calling that 3.5. All right, so that'll be 7/2. Looks like it's right in the middle. Best I can do there. All right, and then we want f prime of 5. Well, that part's easy. That's nice. All right, so remember, derivative is the slope of the tangent line. Right, so we got a diagonal line there. That slope's easy to find. All right, so 2 good points. Oh, it looks like there's lots of good points. So slope here, that slope of that line there at 7/2, or anywhere on that from 2 to 8 there is 1/2, negative 1/2. Right? So that's going to be what f prime of 5 is. Right? Because your derivative is just the slope of the tangent line. Now, if you've got a linear function, it's the slope. It's your slope. Right, so f prime of 5 is negative 1/2. Oh, excuse me. This is supposed to be negative 2. Negative 7/2. So worried about estimating, I forgot the negative. Negative 7/2, negative 1/2. All right, let's find the g's. All right, so go over to the other graph there, and we need g of 5. So if we go over to 5, well, it's a nice value for g. Right there, it's 5. So g of 5 is 5. And then the last thing we need is g prime of 5. Also nice because it's a linear function right there. Right, so we got a slope of 1. Right, so that's what g prime of 5 is 1. So now we'll just replace the values. All right, so switch colors here. We'll make it nice and colorful. All right, so p prime of 5 is equal to, so g of 5 was 5. So we got 5 times f prime of 5 is negative 1/2. think I'm going to need just a teeny bit more space. Oops. Did not mean to make strange pages. Sometimes I just can't find the cursor. It just disappears on me. Hey, where'd my writing go? Uh-oh. Did we accidentally delete the page? Yes. I don't know how. All I wanted was a teensy bit more space. All right, so now I have a little bit more space. But literally, I'm just clicking away, no cursor. I don't know what it's doing. All right, so 5 times negative 1/2, and then minus negative 7/2 times g prime of 5 was 1. Here is 1. Divided by, so g prime of 5 is 5, so that'd be 5 squared. So we have, so p prime of 5 is negative 5/2 plus 7/2 divided by 25. And I'm just going to keep going across here. So that's just going to be 2/2, which is 1, divided by 25. Okay? And what's that value? That is the slope of the tangent line for that quotient. So essentially, we have a rational function. That's what you have when you have a quotient. Right? You combine that into one graph, right? Made that a composite function, right? Then that would be your, or made that a rational function using the two functions there. Be kind of an odd graph, but that would be the slope of that tangent line. It's a lot easier to work with it algebraically than as a graph, I think. All right, so same thing, new graph, or new question. Find the equation of the tangent line to the graph of p of x when x is 5. Actually, just a continuation. We already have the slope of the tangent line, 1 over 25. We need everything else, right? So we have x, right? So x is 5, right? We need our y value, right? So p of 5 is going to be f of 5 divided by g of 5. And we have those things right over there. Right? So f of 5 is negative 7/2. Let's just do it times. G of 5 is 5. Excuse me. We're dividing. Let me do this, which is going to be negative 7/2 times 1/5, right? Dividing by 5, same as multiplying by the reciprocal, so that's going to be negative 7/10. Right, that's a 10. Right, so now all we have to do is write our equation. Right, so y plus 7/10 equals 1/25 times x minus 5. Let's just move the 7/10 over. We're not going to distribute anything. Y equals 1/25 times x minus 5. And then minus 7/10. So that wouldn't be that hard to combine, because we did it with a denominator of 5. But I think that will be fine. All right, let's continue. I think we have just a couple more problems. All right. If you have questions, let me know in class. Let's try this one. All right, so we want r prime of 0, and r of x is sine x divided by f of x. All right, so r prime of x, all right, so let's write the formula first. R prime of x is going to be, our numerator is sine x, denominator is f of x. So it's going to be the denominator, f of x, times the derivative of the numerator. Right? And derivative of sine x, remember, is cosine x. Right? So we're going to have f of x times cosine x, and then minus the numerator, sine x, times the derivative of the denominator. So f prime of x all over the denominator squared. All right, so let's put in the numbers here. So r prime of 0 is f of 0 cosine 0 minus sine 0 times f prime of 0 all over f of 0 squared. All right, so let's find everything. All right, so f of 0 is right there, negative 5. And let's see, f prime of 0. All right, well, now we have to kind of estimate that, but actually it won't really matter that much, as you're going to see. So tangent line there appears to have a slope of 2, I would say, because I'm going 1, 2, and over 1. Yeah, slope of 2. So f prime of 0 is 2. And then what else do we need? We need, well, we know what cosine 0 is and sine 0, right? Cosine 0, that's 1. And sine 0, that's 0. Right, so this is going to be r prime of 0 is negative 5 times 1 minus 0 times 2, which is why it wasn't going to matter if I was a teensy bit off on my estimating there, but I think I did a pretty good job. And then f of 0, negative 5 squared. All right, so that's just going to be, I'm going to write it over here, I guess, is negative 5 divided by 25 is 1/5. Right? Of course, that's our slope of a tangent line. Right? So slope of the tangent line. Now let's find all the other things we need. So we need a point there. All right, so we have sine x over f of x, and it's at 0. All right, so r of 0 would be sine 0 divided by f of 0. Well, that's just going to be 0 over negative 5. Nothing really matters because that's 0. So we have our point. Our point is 0, 0. Right? So we don't really need to use point slope if our y-intercept is 0, 0. So our equation is just going to be y equals 1/5 x. You can put y minus 0 equals 1/5 x minus 0, but it's still going to equal y equals 1/5 x. And this one is done. Right? Nice equation, huh? All right, so let's do some tables. Right? Tables, you can expect to see questions like this on the AP test. We want to estimate the value of g prime of 2.5, and I hope right away you're thinking average rate of change. This is average rate of change. This is your secant line. All right. So it's just going to be, actually this is g's, so I'll use g. So g prime of 2.5 is going to be approximately g of, and now we need the values around is 2.5, right? So 2.5 is right in here. And we want to be as close as possible, so we're going to use these values right here. Right? So, I don't think I really need to write in the 3 there, g there. Right? So g prime of 2.5 is approximately negative 5 minus 2 divided by 3 minus 2. Because you've got one point here, 3 negative 5, and the other point is 2, 2. Right? And so that is negative 7 divided by 1, which is negative 7. So remember, average rate of change approximates instantaneous rate of change, approximates the derivative. On to the next one. If p of x equals g of x divided by f of x, what's the value of p prime of 4? What does this say about the graph of p of x when x is 4? Give a reason for your answer. All right, so we have a quotient rule here. All right, so we're looking for p of 4. So p of 4 is going to be the denominator, f of 4, times the derivative of the numerator, g prime of 4, minus the numerator, g of 4, times the derivative of the denominator. All divided by the denominator squared. All right, so let's find all our values. F of 4 is right here. And g prime of 4 and g of 4, all nice in a row, f prime of 4. All right, so always write your formula first. All right, so f of 4 is 1 times g prime is negative 2 minus I forget who was in the bottom, who was in the top. G of 4 is 7, and then f prime of 4 is 8, all divided by 1 squared. That's easy. All right, so p of 4 equals negative 2 minus 56 divided by 1, so that's going to be negative 58. And what does this say about the graph of p of x when x equals 4? Right, so the graph of p of x is decreasing when x equals 4. And we need a reason. Oops, this pen is smushy. It's hard to write with black. Because p prime of 4 is less than 0. So if your derivative is negative, right, your graph is going to be decreasing. So the graph of p of x is decreasing when x is 4 because p prime of 4 is less than 0. Right? Let's see, I think there might be 2 more questions on the tables, or is that the end? 2 more questions on the table. And then that's the end. All right, so I thought there'd be 4. All right, so q of x equals 2x squared times f of x divided by g of x. What's the value of q prime of 2? And now we have a product rule and a quotient rule. And again, we're going to write out in the equation first. Right, so q prime of 2. Right, so now we have the got to do the product rule, right? And then we got to do the derivative. So q prime of 2 is going to be the first 2x squared times the derivative. Let's just write it like this: d dx, and then we'll break it down. The derivative of f of x divided by g of x, and then we'll figure out what that is. Sometimes it's easier to do one part at a time. And then plus the derivative of 2x squared times f of x divided by g of x. Right. And I'm encroaching again on the other problem. All right, so now let's figure out all these pieces here. Oops. And I guess I just could have just put 2's in there, huh? I'll just put q of x since I didn't put any 2's in there. All right, so then q prime of x. Q prime of x All right, so now let's break this down a little bit more. All right, still going to be the first, 2x squared. The derivative of the second, all right, that's going to be the quotient rule, and so that's going to be g of x times f prime of x. And actually, let's put in the, at this point, let's put in the 2's, so we don't have to write it again. All right, so q prime of 2 is going to be 2 times 2 squared. And then this is going to be g of 2 times f prime of 2 minus f of 2 times g prime of 2, all divided by g of 2 squared. I think I'm going to have to encroach on the next problem. Then plus the derivative of 2x squared. Right, so that's going to be, well, we'll just leave it right now. Just like this, 2x squared. Oops. Actually, we'll write the derivative. That would be 4x, right? Because we could plug in at the next point. Actually, there we go. All right, and then times f of 2 times g of 2. Right, so we already found the derivative of the 2x squared part. And all good except I forgot that parentheses right there. All right, now let's simplify and plug in. All right, so q prime of 2 is, well, that would be 4 times 2, that's 8, times, I'll write that a bit nicer. All right, so g of 2 is negative 1. So we have negative 1 times f prime of times 9 minus f of 2, so 2. And then g prime of 2, negative 1. All divided by, and that would be g of 2 squared, so that's going to be negative 1 squared, and then plus 8, f of 2 is 2, and g of 2 is, where are you? There you are, negative 1. All right, all I got to do is simplify. We're almost done. So q prime of 2, and all this takes is just knowing how doing the rules for product rule, quotient rule. So 8 times is going to be a negative 9 plus 2. So negative 9 plus 2 would be a negative 7, and then divided by 1, so it's just a negative 7. And then 8 times negative 2 is going to be a negative 16. All right, so that's going to just be negative 56 minus 16. It's going to be negative 72. So q prime of 2 is negative 72. There we go. That one's done. Right? It took up a lot of space, but it really wasn't that difficult, right? Let's do the next problem. Find the equation of the line tangent to the graph. So now we want to find an equation. Hope we have enough space there. b of x equals 3x divided by g of x when x is 3. All right, now we got a quotient rule. So v prime of x, actually it's going to be x equals 3, so let's just plug the 3 in. So v prime of 3 is going to be the derivative, yeah, we'll do this right now. Derivative of, so it's going to be the, our numerator is 3x, right? So it's going to be the, actually, you know what? Let's just write it without the 3 in there. So v prime of x, I think it's just easier for me to explain it to you. Okay, so it's going to be the denominator, g of x, times the derivative of the numerator, right? So and then minus the numerator times the derivative of the denominator, all divided by the denominator squared. Now we'll plug in the values. All right, so v prime of 2 is going to be g of 2. The derivative of 3x is just 3, so nothing to plug in there. Minus 3 times 2, and then g prime of 2. Yeah, that's right. Now we'll plug in the values. So, oops, excuse me, g prime of 3. Why did I put 2? Probably because the last problem was 2. 3. So this should be a g of 2. Now it should be a g prime of 3. I mean g of 3. G of 3, I guess it's late. G prime of 3. So 3. Oops, not that one. 3. All right. So finishing this problem off. 3. V prime of 3. G of 3 is negative 3 times 3 minus, so it's going to be 6 times g prime of 3 is 6, all divided by negative 3 squared. Right, so g prime of 3 is negative 9 minus 36 divided by 9. So that's going to be a negative 45 divided by 9, or negative 5. Right, so there's our slope. We just need the point here. All right, so let's solve it up here. All right, so v of 3 would be 3 times 3 divided by g of 3, which is 9 divided by negative 3, which is negative 3. So we could squeeze this in, equation of our tangent line. Would be y plus 3 equals negative 5 times x minus 3. I extend the page just a wee bit so I could squeeze in the last part if I could find my cursor again. There it is. So y equals 5 times x minus 3, negative 5. Negative 5 times x minus 3 minus 3. And if you want, we could put it in slope-intercept form, or y equals, that'd be a negative 5x, that'd be a plus 15, and a minus 3, so that'd be a plus 12. Either is fine. All right, and that's the end of this podcast. Thanks for watching, and I hope quotient rule is nice and clear for you. Bye for now.